Introduction to CERN's latest discoveries. Within the shadow of Geneva, beneath the surface of our world, exists a marvel of human creativity, and a potential precursor to destruction, the Colossal Hadron Collider, LHC. This apparatus serves as an unparalleled tool for specialists, allowing them to investigate subatomic particles and uncover the enigmatic God particle, the Higgs boson. Distinguished physicist Brian Cox has offered a chilling explanation that has stirred mixed emotions among scientists, prompting them to examine the fundamental components of matter and scrutinize the very essence of spacetime. Despite the immense effort required, these experiments also pose significant dangers, both recognized and unrecognized. One of the foremost concerns surrounding the operation of the Massive Hadron Collider is the potential generation of miniature black holes or other extraordinary phenomena that could yield unpredictable outcomes. While theoretical models suggest that any such black holes would be fleeting and pose no threat to Earth or its inhabitants, the risk of inadvertently creating horrors beyond our control remains unsettling. Furthermore, the vast scale and intricacy of the experiments conducted at the collider necessitate rigorous safety protocols and oversight to mitigate possible hazards. The international community of researchers and scientists, the following people are involved in the collider's operation, are acutely aware of the imperative to prioritize safety and ensure that all experiments are performed with the highest degree of caution and responsibility. The Large Hadron Collider, with its ability to astound and challenge our comprehension of reality, is not merely a triumph of modern engineering but also a crucial hub of contemporary particle physics and cosmology. Its primary goal is to investigate the fundamental particles that constitute the universe, carrying profound implications for our understanding of existence. The LHC allows scientists to replicate conditions just moments after the Big Bang, offering a remarkable opportunity to study the Higgs boson and other essential particles. The Higgs boson, often termed the God particle, was postulated in 1964 by Peter Higgs and colleagues as a vital element of the Standard Model of particle physics. This model delineates the fundamental forces and particles that compose the universe. The Higgs boson's identification at the LHC in 2012 validated the existence of the Higgs field, an invisible field that imparts mass to other particles. This finding marked a significant achievement, confirming decades of theoretical exploration and enhancing our comprehension of the universe's hidden structure. Nevertheless, like all major scientific pursuits, the quest for knowledge at the LHC is not devoid of potential risks and ethical dilemmas. The energies involved in particle collisions at the LHC are staggering, and the likelihood of generating new forms of matter or instigating unforeseen reactions cannot be entirely dismissed. Some scientists have speculated about scenarios where high-energy collisions could create small black holes or other unusual particles, raising alarms about the potential consequences of such occurrences. While the majority of experts deem these risks to be exceedingly remote, the very essence of scientific inquiry entails venturing into the unknown. Brian Cox's assertion, emphasizing the possibility of creating, within itself, a miniature Big Bang, underscores the immense significance and possible dangers of this research. The Large Hadron Collider epitomizes the zenith of contemporary scientific endeavors. However, its extraordinary capabilities also get people talking in a fundamental way about the limits and responsibilities of scientific exploration. The collider, through its design and functionality, seeks to address fundamental questions regarding the universe, yet it operates at the periphery of human understanding and technological proficiency. This intersection leads to significant questions regarding the nature of science, scientific risk, and the ethical ramifications of such advanced research. One of the most exhilarating aspects of the LHC is its capacity to simulate conditions shortly after the Big Bang, providing captivating insight into the early universe. This replication allows scientists to investigate particles that existed during the universe's early phases and examine phenomena that would otherwise be challenging to access. By bringing these extreme conditions back to life, researchers can evaluate theoretical predictions and refine models of particle physics. For instance, experiments at the LHC have the potential to scrutinize the properties of hypothetical dark matter particles, which are believed to constitute a substantial portion of the universe's mass but remain elusive to direct detection. The pursuit of understanding dark matter's profoundness propels it. Its implications for our comprehension of the universe are immense. Currently, dark matter is inferred from its gravitational effects on visible matter, but direct detection remains problematic. The LHC's goal in experiments is to address this issue by trying to produce dark matter particles in the laboratory. If successful, this could revolutionize our grasp of the universe and potentially lead to groundbreaking discoveries and insights. Such advancements highlight the LHC's role as not just a scientific instrument, but also a catalyst for transformative discoveries that could change how we see the world in a new way. Another captivating area of inquiry involves the strong force, one of the four fundamental forces of nature. The strong force binds protons and neutrons within atomic nuclei, and comprehending its behavior at elevated energies can yield insights into the fundamental structure of matter. The LHC's ability to investigate strong force interactions on an extreme scale enables scientists to explore the dynamics between quarks and gluons, the fundamental particles that mediate the strong force. These investigations could lead to a deeper understanding of nuclear physics and the forces that govern atomic behavior. The technological progress fueled by the LHC extends far beyond particle physics. The collider's complex systems for detecting and examining particle collisions have sparked innovations in computing, data analysis, and sensor technology. For example, the development of the World Wide Web was originally envisioned as a means for researchers to exchange data from particle physics experiments at CERN. Today, this technology has revolutionized global communication and information sharing. The advancements in computing and data management prompted by the LHC have had a widespread effect across various fields, demonstrating how significant scientific research can drive technological advancement. However, operating such a powerful device necessitates strict safety protocols and ethical considerations. The possibility of unforeseen outcomes, such as the creation of new or unusual particles, requires a careful risk assessment. Despite the fact that theoretical models suggest the chance of catastrophic events is extremely remote, this possibility cannot be entirely ruled out. This uncertainty urges scientists to approach their work with caution and transparency, ensuring that safety measures are robust and that the public is informed about potential risks and the strategies implemented to mitigate them. Public involvement and comprehension are crucial aspects of specialized research in the early universe in a controlled laboratory environment. By accelerating protons to near light speed and smashing them together, the LHC recreates conditions not seen since just after the Big Bang. These collisions produce a burst of energy that can briefly form exotic particles, some of which may have existed only in the first moments of the universe's formation. In these ephemeral flashes of raw creation, scientists glimpse particles that decay almost instantly, leaving behind trails of information for researchers to analyze. These traces are recorded using incredibly sensitive detectors, capturing data that must then be parsed and interpreted using advanced computing systems. Yet, with such immense power comes an even greater demand for vigilance. Physicist Brian Cox has stated that the LHC's capacity to produce events mimicking the Big Bang could, in theory, unravel the very threads of spacetime, if improperly handled. While the mainstream scientific consensus assures that this risk is vanishingly small, the notion itself compels one to consider the scale and scope of this experiment. What if we are not just observing the universe, but tampering with its code? This question lies at the heart of ethical debates surrounding high-energy particle physics. Are we prepared for the consequences of discovering something that fundamentally alters our conception of reality, or even disrupts it? Could we inadvertently unlock dimensions we do not fully understand? Theoretical physics is increasingly brushing against such limits, from extra dimensions predicted by string theory to the potential creation of wormholes or false vacuum decay, scenarios once confined to science fiction. Although these possibilities remain speculative, they raise the stakes of every experiment conducted at CERN. Moreover, some researchers have noted anomalies, brief, unexplained fluctuations in the data that don't fit current models. While these could be the result of statistical noise or minor equipment calibration issues, they may also hint at new physics beyond the standard model, a framework already known to be incomplete. There are particles and forces we've yet to detect. The LHC's increasing energy levels aim to reach deeper into this unknown, but with each new upgrade, the pressure mounts to ensure that scientific ambition does not outpace ethical responsibility. Outside the scientific sphere, conspiracy theories and fringe interpretations often fill the public's knowledge gap. Claims that the LHC is a portal to another dimension, a weapon of mass destruction, or even a gateway for entities beyond human comprehension circulate widely on the internet. While these ideas are unsupported by evidence, their persistence underscores a deeper truth. The public is both fascinated and fearful of technologies that outstrip their understanding. Thus, CERN and the global scientific community face a dual task: to pursue the truth about the universe, and to do so in a way that invites public confidence rather than fear. In recent years, new collaborations between physicists, ethicists, and communicators have emerged. Their goal, to ensure that projects like the LHC operate transparently, with input not only from the scientific elite but from a broad cross-section of humanity. These discussions don't hinder science, they protect its integrity. They are reminders that in the pursuit of unlocking the secrets of the universe, we must not forget the world we live in. The Large Hadron Collider remains one of the most ambitious undertakings in human history. It is both a cathedral of knowledge and a crucible of uncertainty. Every proton collision brings us closer to answers, and sometimes closer to questions we never anticipated. Perhaps that is what makes it so profoundly human. The universe's inception. This monumental apparatus allows us to unlock the mysteries of the cosmos, revealing something truly groundbreaking and potentially transformative. CERN, established in 1954, is among the world's most prestigious research institutions, comprising 23 member states and a vast network of scientists. The LHC is CERN's flagship initiative, but it is merely one element of a larger system, a system of accelerators and detectors that explore the subatomic domain. The LHC accelerates protons to nearly the speed of light, replicating the energy present at the moment of the Big Bang. The resulting collisions create temperatures millions of times hotter than the Sun's core, with a complex array of magnets guiding the protons on their journey, while advanced cooling systems maintain the magnets at temperatures colder than outer space. The design of the LHC is an engineering marvel. Operating deep underground and shielded from cosmic radiation, the entire ring is cooled to temperatures below those of the vacuum of space, essential for the superconducting magnets to function effectively. Collisions occur at 4 points along the corresponding accelerator rings, aligned with one of the 4 major particle detectors, ATLAS, CMS, ALICE, and LHCb. These detectors capture the aftermath of collisions, enabling scientists to sift through the debris in search of the elusive Higgs boson, a particle crucial to understanding the universe's structure. The LHC is not just a scientific instrument, it is also a testament to human imagination and ambition. It embodies our quest for knowledge and our desire to comprehend the fundamental factors that determine our universe. Nonetheless, as we test the limits of understanding, we must also consider the moral and existential questions that arise. The ambition to recreate conditions akin to those of the Big Bang carries profound responsibilities, and the pursuit of knowledge should never come at the expense of safety. The process of scientific discovery frequently involves moments of awe, wonder, and the unknown. The Large Hadron Collider, LHC, serves as a testament to humanity's unyielding curiosity and the drive to unlock the deepest secrets of the universe. Despite its immense potential to reveal the nature of matter and the origins of the cosmos, the LHC also calls for harmony between exploration and caution. As we delve deeper into the microscopic world, it becomes evident that the LHC is not just an engineering marvel but a symbol of the intricate relationship between science and society. CERN's vision extends beyond the LHC, with ongoing efforts to explore the unknown realms of physics, such as the quest for a unified theory of everything. While the LHC's experiments focus on particle interactions at unprecedented energy levels, the goal remains to answer some of the most profound questions of existence. How did the universe begin? What are the fundamental forces that govern everything? Could there be other dimensions of existence? These questions, though theoretical, push humanity's scientific boundaries further than ever before, allowing us to dream of solutions that once appeared out of reach. Despite these breakthroughs, the scientific community must continually address ethical concerns. A significant issue involves ensuring that the LHC's discoveries are utilized responsibly. With such revolutionary potential comes a responsibility to ensure that the knowledge gained from these experiments does not unintentionally harm or lead to unforeseen consequences. As new particles or interactions are uncovered, it is essential that their implications are fully considered, and that global governance frameworks are in place to guide the use of this knowledge. The LHC's discoveries could have profound effects on areas beyond physics, including medicine, energy, and technology. For example, advancements in accelerated technology may lead to better cancer treatment options, while the ability to comprehend fundamental particles aids scientists in developing more effective energy systems. Collaboration plays a key role in the future of the LHC. The project involves a global network of engineers, scientists, and researchers from diverse backgrounds and disciplines. This collaborative spirit is essential for the LHC's ongoing success and for addressing the challenges it presents. As we move forward, it will become increasingly important to foster international cooperation in scientific exploration. The LHC exemplifies how nations can work together to advance knowledge for the betterment of humanity, transcending geographical and political boundaries. In a world where scientific discovery often occurs at the intersection of disciplines, the exchange of ideas and expertise is crucial for progress. The LHC's role in advancing our understanding of the universe, though profound, is only one part of a larger picture. The experiments conducted at CERN are paving the way for future generations of researchers to take the subsequent step in comprehending the forces of nature. As the LHC continues to operate and new discoveries unfold, it will shape the future of science and continue to challenge our perceptions of reality. As we stand on the edge of new scientific frontiers, it's crucial to remember that our exploration should not only seek knowledge, but also respect the ethical considerations that come with wielding such immense power. The questions we answer today may shape the world for generations to come. Conclusion and final thoughts. In conclusion, the Large Hadron Collider represents the pinnacle of human accomplishment in scientific exploration. Its vast potential to unravel the mysteries of the universe is matched by the significant risks associated with its operation. As scientists delve deeper into the fabric of reality, it is essential to remain vigilant, ensuring that the quest for understanding is conducted with the utmost responsibility and care. As we stand on the brink of discovery, the question remains: are we prepared to embrace the forces we are about to unleash? Beyond the collider, the future of fundamental discovery. While the LHC has already made monumental contributions, most notably the confirmation of the Higgs boson, its true legacy lies in the new questions it inspires. The standard model of particle physics, though incredibly successful, remains incomplete. It does not fully explain dark matter, dark energy, gravity, or the asymmetry between matter and antimatter in the universe. These mysteries compel us to look beyond current limitations. Projects such as the Future Circular Collider, FCC, currently under conceptual development at CERN, aim to explore higher energy levels and more exotic phenomena. Such initiatives reflect a broader ambition, not only to refine existing theories but to reach entirely new paradigms in understanding the cosmos. This journey is not purely academic. The practical offshoots of high-energy physics, such as medical imaging technologies, superconducting materials, and advanced data processing algorithms, demonstrate how deep theoretical work can ripple into everyday life. As we push boundaries in physics, we also push the boundaries of what is possible across disciplines. Ethics, responsibility, and the human element. Yet, progress is never without consequence. As our understanding of the building blocks of existence deepens, so too does our capacity to manipulate them. This reality calls for robust ethical frameworks, both to govern experimentation and to ensure that the fruits of discovery are shared equitably across societies. We must ask, who controls the outcomes of these discoveries? How do we ensure access, fairness, and global dialogue in shaping the uses of new knowledge? The answers lie not in technology, but in humanity, in transparency, inclusivity, and humility. Scientific advancement is not solely the domain of labs and equations, it is an inherently human enterprise. The awe that follows discovery should also be accompanied by reflection. In probing the very origins of the universe, we are, in a way, confronting the essence of ourselves, our place, our purpose, our future. Final reflections, a legacy in motion. The Large Hadron Collider stands as a living legacy, one that will evolve long after its current experiments conclude. It has already reshaped our understanding of matter and energy, but more importantly, it has reinvigorated global curiosity and collaboration. In a world often fragmented by conflict, science offers a rare unifying force. The pursuit of truth, of understanding, is one of the few endeavors that transcends borders, beliefs, and politics. It reminds us that despite our differences, we are all inhabitants of the same mysterious universe, driven by the same fundamental questions. As we peer deeper into the quantum fabric of reality, the greatest discovery may not be a particle or force, but a deeper recognition of our shared destiny. The path forward will demand courage, cooperation, and conscience, but the potential rewards are limitless. Let the LHC be not only a scientific triumph but a beacon, proof that human intellect, when coupled with wisdom and responsibility, can illuminate even the darkest corners of the unknown.